All right, so we're going to use the integral test to determine what's true about this series. So it's asking if it converges or diverges, and it's really asking for the reason. So we're going to use the integral test here. This is in terms of n. It is decreasing because n squared is increasingly getting larger and larger, and this is getting smaller, so it is increasing. It is going to be positive. We're going to use the integral test. So we're going to integrate the related function, which would be e to the 1 over x over x squared with respect to x, and we're going to go from 1 to infinity. Now, if this integral converges, we'll know that this sum also converges. So now we have to remember how to integrate this. The best thing would be if we can integrate e to the u. In other words, let u be 1 over x. And if we do let u be 1 over x, you'll see very quickly that 1 over x is x to the negative first. So du would be negative x to the negative second, or negative 1 over x to the positive second dx, which is a great substitution here. So we're going to take the limit as a goes to infinity, or let's go b because it's an upper limit, as b goes to infinity of this integral. We're going to have, with our u substitution, it's going to be negative, because the negative 1 over x squared, e to the u, du. So the integral of e to the u is e to the u. So we have a negative, that's the constant. I can take it out of that, both the integral and the limit, which I'm going to do. As b goes to infinity of the integral of e to the u, again, is just e to the u. So I'm keeping my limits in terms of x. So I want to make this e to the 1 over x. And we're evaluating from 1 to b. So, and this is a multiple choice question. You can do this much quicker. You don't have to show all the limits and stuff like that. So we have, negative the limit as b goes to infinity of, we have e to the 1 over b minus e. So when you plug in b, 1 over infinity, that's going to go to, that exponent's going to go to 1 over infinity, which is 0. So it's going to be e to the 0, which is 1. We still have that negative out in front. So I'm going to distribute the negative, and this integral actually converges to e minus 1. So when I look at the choices, it does converge, so I don't have to worry about this one. But it converges because this integral turns out to be e minus 1, which is this. So that's an example of the integral test for you.